Hello all, today we are going to discuss lesson 2.5, scatter plots and lines of regression. Alright, so in the past, you learned how to write linear equations. So today we are going to construct or use scatter plots and prediction equations, and then model data using lines of regressions. Okay, vocabulary: bivariate data, scatter plot, dot plot, positive correlation, negative correlation, line of fit, and prediction equation, regression line, correlation coefficient. Okay, so first, make sure you take notes of this. These are the different kinds of correlation. So the first one is positive correlation. So the second one is negative, and the third one is no correlation. So let's talk about the positive correlation first. So you have noticed that the points, after you plot the points, they are more or less clustered on the same direction. If you're gonna draw a line, your line has a positive slope, so the points are moving towards the right. Okay, so the slope of the line is positive and the points are close to the line. That means positive correlation. Okay, negative correlation. You can also call this one as weak negative correlation. The slope of the line is negative and the points are not close to the line. So if you look at the points, they are clustered and moving towards the left. Okay, so opposite to positive. So if you're going to draw a line of best fit here, the points are more or less surrounds the line and moving towards the left. Okay, negative correlation. So no correlation, meaning the points are just scattered. There is no obvious pattern of increase or decrease for the given data. Alright, let's continue. So let's try to apply. Use a scatter plot and prediction equation. The table below shows the approximate percent of students who sent applications to 2 colleges in various years since 1985. Make a scatter plot of the data and draw a line of fit. Describe the correlation. Okay, so this can be your x sub 1 and then y sub 1, x sub 2, y sub 2, and so on. Okay, so these are your x's and these are your y's. And then go ahead, plot the points. So it looks like this. So up 0, 20, so 0 up 20. Then you have 3, 18, so 3 up 18. And then 6, 15, 9, 15, 12, 14, 15, and 13. So I hope this time you can still remember how to plot points. Okay? So if you look at the points, they're moving towards the left. Okay? So you can draw a line through these 2 points. So just connect 2 points after you plot the points. So the data show a strong negative correlation. Okay? And the line that you draw connecting 2 points is what you call as the line of best fit. Alright, let's move on to the next. Use 2 ordered pairs to write a prediction equation. So we're going to use 2 points in the graph. So in this example, we're using 3 and 18, 15 and 13. So let's start with finding the slope of the line. So plug in. So this can be your x sub 1, and then y sub 1, and then x sub 2, and then your y sub 2. And then plug in the formula. Okay? Alright, so continue. 13 minus 18 over 15 minus 3. negative 5/12. So that's the slope of the line. And then we're going to use the point slope form so that we can create an equation. So in this case, we're using your 0.3 and negative 18, or 3 and 18, I mean. So distribute negative 5/12, distribute negative 5/12 to negative 3. So that will turn into positive 1.25, and then you add 18 both sides. So you will get negative 5/12x plus 19.25. So this is what you call as the prediction equation. Okay, so that's how you use the formulas. Okay, now we're going to predict. Using the equation that we just made, we are going to predict the percent of students who will send applications to 2 colleges in 2010. So when x is 2010, what will be your y, the percent of students? So just use the equation that you just created. So this was the equation that we created, and then you plug in 20, that would be year 2010, that would be 25 years after 1985. Okay, so we just subtract 2010 minus 1985. Okay, so x is going to be 25. So plug in 25 equals x. Alright, and then simplify. 5 times 25 divided by 12 plus 0.19.25. So you will get 8.83. So this is the percent of students who will send the application in 2010, 25 years after. Okay? 8.83%. Alright, so how accurate is this prediction? So let's take a look. Except for the point at 6 and 15, the line fits the data well, so the prediction value should be fairly accurate. Alright, check your progress. Try the next problem. So years will be your x's, and then your percent's gonna be your y. So which shows the best line of fit for the data? So let's take a look. A, B, C, or D. So after you plot the points, you'll be able to determine which of the 4 graphs is the best answer. Alright, so let's take a look. So it should be letter C with positive correlation. Alright, so next question. What is a good prediction equation for this data? So we're going to use the points 6 and 71, 12 and 81. So you're going to use your slope formula and then your point slope formula. So let's start with the slope. So this will be our x1 and this will be our y sub 1. This is your x sub 2 and this is your y sub 2. So start with finding the slope. So slope equals 81 minus 71 all over 12 minus 6. So you will get 81 minus 71 is 10 over 12 minus 6 is 6. So approximately that's 10 over 6 divided by 2, each of that top and bottom number. So you have 5 over 3. Okay? Alright, so you can already see that your slope is positive. So which of this has slope of positive 5 over 3? So it's going to be this. Okay? Or you can continue and use the point slope formula. Y minus y1 equals m times x minus x sub 1. Okay? And then you just decide which of the, between the 2 points you're going to use. You can use this to plug in y1 and x1 and then get the answer. Alright, let's see if our answer is right. Okay, correct. Okay? Alright, next. Predict the percent of drivers who will be wearing seat belts in 2010. Okay? So you're going to subtract 2010 minus 1994. How many years after? So that would be 16. So x equals 16. So you're going to plug in. So plug in 16 in x and then simplify. So you will get y equals, what is 16 times 5? Plus 61. Okay? So that will give you what? 5 times 6 is 30. Carry 3. So 80 over 3 plus 61. Alright, so what's your math there? So you will get 26.7 plus 61. So your answer is going to be 87.6. Okay? Alright, so the best answer is 87%. Alright. How accurate is the prediction about the percent of drivers who will wear seatbelts in 2010? Were there outliers except for one, or there's none? Alright, so the best answer here is, except for the one outlier, the line fits the data very well. Okay. So the table shows the median income of families. Use a graphing calculator if you have. If not, just make a scatter plot. Find the equation and graph a line of regression. Then use the equation to predict the median income. So basically, this is similar to what we did in the previous examples. So let's take a look. So scatter plot, plot all the points. So you can only do this, guys, if you have a calculator, scientific calculator. But if you don't have, no worries. You don't need to do this. Okay? And then graph the regression equation. So these are just steps for you to use in your calculator. Alright, just in case, if you have one, you can also compute linear regression using the steps in your calculator. Okay? Alright, so I think that ends the lesson. Thank you for listening. Hope you learned something. Bye for now.